Now that we have Thymeleaf-based web application layout setup in place, let us focus on database setup, and then we'll configure Spring Data JPA and talking to PostgreSQL database. So we are going to use Spring Boot support for Docker Compose to run the PostgreSQL database as a container. And we are going to use Flyway for database migrations. So let's get started. When we generated the project, we have added many starters that we are going to use, but then we commented out so that we are going to add only the starters that we are actually using. So here, let's start with adding Spring Data JPA starter. So as we have already talked about, Spring Boot is a opinionated framework, and when you want to work with Spring Data JPA, you add this Spring Boot starter data JPA, which transitively pulls Hibernate dependencies because Hibernate is the most popular JPA specification implementation. So now if you just add this dependency, and then if you try to start your application, and Spring Boot automatically tries to load the application and then try to connect to a database, but we haven't configured any database connection properties or anything else. So you can see application failed to start, and then it provides some error messages saying that if you want to use an embedded database, put a driver of any of these in-memory database drivers in class path, or if you are running a database outside and you want to talk to that, you need to set up those properties, JDBC connection properties. So let's start with adding a in-memory database driver here. We have H2 selected, so I am adding this and reloading the configuration. And now if I run the application, here in the logs you can see Spring Data JPA is configured to talk to H2 database with in-memory settings. So here you can see we are using JDBC H2 in-memory based data source, and if you do any database operations, it is going to try to talk to H2 database. It is nice to get started with such a in-memory database, especially if you are doing a proof of concept or a simple demo, that is fine. But most of the times we work with some real databases like MySQL, PostgreSQL, Oracle, or something like that. And we want to use PostgreSQL for our blog application. So how do we do that? Like, one option is you can go ahead and install PostgreSQL based on your operating system. You may want to download and then install, and then you can talk to that. I personally prefer to simply run it in a Docker container, so that whenever you want to spin it up, you can do it. And if you don't want to run it, you can just simply delete the container. So it is much simpler. So what we can do, we can create a Docker Compose file and then configure PostgreSQL service and then start it manually. But in Spring Boot 3.1.0, Spring Boot makes it much simpler by providing explicit support for local development using Docker Compose. So you can add a dependency that supports Docker Compose integration, and then it will create a Docker Compose file with based on what services you added. So here, if you take a look at it, while creating this application, we have selected Docker Compose support, and then we have selected PostgreSQL also. So then it automatically created this compose.ml file by configuring this PostgreSQL. So we have seen we just added only H2 database, but this is not what we really want to use. So I'm again moving it into commented out section, and I want to use PostgreSQL. So I will add this PostgreSQL driver here. Okay, and also as I mentioned, Spring Boot provides Docker Compose support. So this is the dependency I am going to add here. And if you notice, this is going to be used only with the runtime scope and optional equals to true, because we don't want to bundle the dependency Spring Boot Docker Compose into the final over jar, fat jar. we are going to use this only during the development time. So by making it as optional, when you finally build a fat jar, this dependency is not going to be bundled in that fat jar. So this is going to be useful only during the development time. So with this added, and you have compose.yaml file, and it supports all these variations, docker-compose.yaml file, compose.yaml file. So you can use any name you want. So by default, we have this compose.yaml file. And one thing to note is here, when we generated this application, by default, it uses this Postgres latest. But it's not a really good practice to use the latest tag, because that's going to change. Today, this could be Postgres 16, and probably down the line, few months later, it could be 17, it could be 18, something like that. So to make it explicit and predictable, I highly recommend to use a specific tag, whichever version you want to use in your production, explicitly configure that. And also you can leave this database name, username and password as it is, but I personally prefer to use Postgres for all of this, but it is not mandatory. You can just leave them as defaults. And also when you have this ports configuration, so when you just mention this container port, when you start the PostgreSQL container using Docker Compose, it is going to allocate this containers 5432 port onto a random available port on the host. But I want to connect to this database container from my IDE or from any other database client tool on a fixed port. So I am going to make it available on host 5432 as well. Maybe if you want to change it, you can change it, but I'm going to use 5432 on the host as well. So with this configuration, if I start the application now, it is going to automatically start a PostgreSQL container and configure the application to talk to this database. So in Springboot 3.1.0, when this support for Docker Compose is introduced, it also comes with this concept of service connection, which means Docker Compose support automatically recognizes some containers and automatically tries to configure them, even though you are not explicitly configuring the properties to talk to that PostgreSQL. Spring Boot figures out, okay, this is a Postgres container and there is a Spring Data JPA dependency added, so it's going to register the container details as JDBC properties and register the data source bean. So by simply adding this dependency and having this compose.yaml file, Spring Boot will recognize this PostgreSQL and then automatically configure your application to talk to this PostgreSQL database. You don't have to configure in application.properties file. You can simply have this dependency and let Spring Boot does its magic. So now if let's take a look at the Docker containers. So here, if you take a look at, I have one container running, but we don't have any PostgreSQL containers running. Now, when I start the application, it's going to automatically spin up a PostgreSQL container and configures the application to talk to it. So let's check. Here we can see there is a PostgreSQL container running. Okay, and if you take a look at the application logs, here you can see it is using now it is using PostgreSQL database connection, not H2A anymore. So we have our database setup in place. So again, this is good enough for a local development environment, but if you want to configure your data source properties explicitly to some existing PostgreSQL database, you can use that. Say, so typically you configure, so I just used a live template so that I don't have to type it again and again. So here, this is how you usually configure your database properties. What is the URL, username and password, and while using JPA, we'll talk about what is open in view property, and you want to validate whether your JPA mappings is in sync with the database structure. So these are some of the properties that I commonly use. So you can configure these data source properties, or you don't need to. When you are doing local development, Spring Boot automatically register this using service connection. But if you want to explicitly configure this, this is also fine. So here is the thing. Even though you have these properties configured, when you are using Spring Boot Docker Compose support, whatever the values you provide here will take higher precedence than what you have configured here. So here you can configure, let's say 45432. It's invalid. I don't have any PostgreSQL running on 4532. So if I restart the application, it's not going to take these parameters into account. Instead, it's going to spin up a database using these properties and automatically configure data source bean using these properties. So these are not going to be priority. These are going to be priority. So you can see application started just fine. So this is how Spring Boot Docker Compose support helps in starting any such dependent services like databases or Kafka, RabbitMQ, or Redis, or whatever the containers you want to use for your application. So we have our database ready, and we have added our PostgreSQL driver. We have added Spring Boot starter data JPA dependency. So next, let's create our database table structure using Flyway migration tool. So here again, we already have the Flyway migration support libraries. So here there is a Flyway core, which is the core library, but then depending on the type of database that you are using, you need to add a specific library that supports your database. So here we have Flyway database PostgreSQL dependency as well. So I'm going to move these two things here. So Spring Boot provides auto configuration support for Flyway. So typically with Flyway, you write Flyway migration scripts using SQL, and then you specify what are the database objects that you want to create, be it tables, indexes, or whatever. So, and you put those scripts under SRC main resources DB migration folder, and you typically follow a pattern like here V1. So it can be 1, 2, 3, 4 in the sequence, and you can give any descriptive name. I'm going to simply create a tables.sql. So it's not 1 underscore, it's 2 underscores. So this is the naming pattern that you need to follow while using Flyway migrations. So V, that's a prefix versioned migrations, and you give a number, sequence number, and we are just starting, so our first version number is 1, and this is a separator. 2 underscores is the default separator, and you can give any descriptive name. I don't know, here I am just giving create tables and data SQL. So here I have already prepared the script, and what we are doing, we create a sequence that starts with 1 and increment by 50, and we are creating a table, and for users table we have email, password, name, role. So there can be different roles like admin or normal user, and email should be unique. So nothing much. And again, similarly, we have post sequence and post table. We have post title, slug, and actual content, who created and when it is created. So again, no big deal. We have finally a comments table and a comment sequence, and for which post this comment belongs to, and then who posted it, and their email ID, and actual post content. So again, nothing complicated here, simple 3 tables, and we have that our first Flyway database migration script. And in our pom.xml, we have both Flyway and Flyway database PostgreSQL dependency. So we are all set. And one thing, when we add a Spring Boot's Docker Compose support, when we are running this application, the container will keep running. And if you stop the application, here you can see the container also stopped. But during the development, I don't want to keep on stopping and restarting. Instead, I want it to run in the background all the times. So what I can do in application.properties file, I can specify a property compose lifecycle start only. By default it is start and stop. You can see it is showing as default also, but I just want to start. When I stop the application, I don't want to stop the containers. I want them to keep running in the background, so I'll set it to start only. Now with this, if I start the application here, let's go and check the Docker container. It is running now, and if I stop it, still it continues to run. It's not stopped. So fine, we have the Docker setup ready, and we have our first migration scripts. Let's start the application, and because we have configured explicitly to map it to 543T on the host as well, we can connect to this database. So here I am using IntelliJ Ultimate Edition, so I have this database tools support. But if you are using Community Edition, you might not have this database tool support. Probably you can use Ultimate Edition trial version, or you can use any other database client. So here you can connect to PostgreSQL, and the port is 5432, host is localhost, database is Postgres, user and password are also Postgres. So I am able to connect to the database, and when I connected, I should be able to see the database objects created, like we have comments table and posts users tables, and there is a Flyway schema history table in which it keeps track of what are all the migrations that are already applied. Here you can see the first migration script is already applied successfully, and it also calculated this checksum and then store its value. So which means once a migration script is applied, you are not supposed to change it by whatever small change. You are not supposed to change it. Let's say let's add one more column at one, just to demonstrate. So if I restart this application, here it's going to fail, saying that here typically if you see error something like this, applied to database this, resolve locally, this means you changed an existing Flyway migration script that is already applied. So you are not supposed to do that. So to make any changes to the existing database, you are supposed to create a new migration script and then write the SQL to change the database. So let's restart, and it should work fine. So now it started fine. So now that we have our database migrations in place, and let's go ahead and start creating the entities and repositories. Now we can start creating the JPA entities, users, post and comments. So what we can do, we can go ahead and create a Java class user, and then I have some IntelliJ live templates that I can use to just create some basic skeleton like this. And then if I want to create a JPA entity ID, again I have a live template that uses sequence, so like this. So we have entity, user, and also we can give a name, explicit name if it is not matching with the default user. So we have our table name as users, right? So I'm giving this name, and this is how we can go ahead and manually create and then add the properties and specify all the column and nullable, false, unique and everything. So you can manually go ahead and add the properties and everything. But if you have IntelliJ IDEA Ultimate, you can generate the entities from database schema, so you don't have to manually create them. So to do that, you should have that connection created here, and now you can go ahead and use this JPA entities from DB, and then it will show all the database connections. Here we have only one, and then you can specify under which package you want to generate those JPA entities. So I want to generate the JPA entities under domain package, and then I want to generate a JPA entity with class comment for the comments table. And also here you can see it by default it maps with all the properties to sensible default Java types. And also here we have many-to-one association with post. By default it is not selected. If I select this, which means we also need to have a JPA entity post, so it automatically checked. And here if you take a look at it, here again there is a many-to-one association to user. So when we checked it again, user also checked. And here you can have a reference to a set of comment entities, but I don't want to hold them. Instead I want to have a many-to-one association only, not one-to-many. So I leave this, and this is it. All the properties are selected, and you can also see it identifies it is using a sequence based identity generator, and then populate these names also. So let's select this, and here you can see it generated all the entities with all the mapping details in sync with the database structure. So this is how simple you can create the entities if you have IntelliJ IDEA Ultimate Edition. And we have the entities, comment, post, user, and also you can see the associations like from post to user you have many-to-one association. By default it will be lazy loaded. So everything is ready. And also we are not using Lombok, but if we are using Lombok, instead of generating these setters and getters, it will use @setter, @getter annotations instead of generating these. So IntelliJ identifies you are using Lombok and then or not, and then depending on that it will take necessary action to generate these or use Lombok annotations. So we have our entities ready. Now let's go ahead and create Spring Data JPA repositories. And again, while using Spring Data JPA repository, you need to think about, you are not going to create a repository for every entity. Instead, you usually create a Spring Data JPA repository for a aggregate. If you are familiar with DDD, domain driven design, you might understand like there is a entity, and then there is aggregate, value objects, and things like that. So you usually create a repository for an aggregate. In our case, let's go ahead and create the entity Spring Data JPA repositories for all of them, because somewhere down the line we are going to use them. So here again you can see Spring Data JPA repository. Again, this is a feature in IntelliJ IDEA Ultimate only, but if you do not have, or you are using Community Edition, you need to create this manually, something like this. So here, if you are using Community Edition, go ahead and create a class, actually an interface like user repository, and it's an interface, and you need to extend either JPA repository or CROD repository or things like this. And if you are using Ultimate Edition, you can go ahead and you can select okay, I want to create a comment repository, and you can say okay. Or if you want to create more than one repository, you can select both comment and post, and it will generate this user repository, post repository, and comment repository. So this is how simple it is. If you want to use IntelliJ live templates that I used in the video, so here if you go to my GitHub account, and then you can find this IntelliJ live templates repository, and here I have created a bunch of live templates that I use often, and you can follow these instructions to import into your IDE, and then you can use them. And also if you are if you like reading a blog post than watching a video. And here recently I have published a couple of articles on IntelliJ blog. Here is a first article, how to build a CRUD REST API. Though it is a REST API, many things you can still follow along to learn how to use Springboot. And then there is another article which is kind of a sequel, like how to use Flyway for database migrations. So if you are like me, who likes to read an article, and probably these two things might be interesting for you to check out. So I hope this video is helpful, and thanks for watching. Stay tuned for the upcoming videos. Bye bye.